Okay, year six, so welcome to your maths lesson, first maths lesson for the week, and your learning objective is to be able to find the volume of cuboids. So we looked at 2D shapes, and we looked at the area and perimeter of triangles, parallelograms and rectangles last week. So now we're looking at volume now. Think about the units when we did our units of measurement that volume was going to be in. To have a think. And then a cuboid is a 3D shape that you can see on here. Okay, so each small cube has a volume of 1 centimeter cubed. Okay, that 3 means cubed, so we had centimeters squared for area, and now for volume we have centimeters cubed. So we have to find the whole find the volume of the whole cuboid. Okay, now we've got an idea here on our orange square that says 4, 5 and 3. Now think about what you might have to do with those measurements. Notice the units, and then eventually you will be able to work out this is a prism, which is a type of cuboid, but for now we're just looking at the orange one. Okay, so the keywords are area, cross section, cylinder, prism and volume. Don't worry about cylinder or prism too much yet though. So just as a little starter, you can pause here and think how many small cubes are in each of these cubes or cuboids. If you have any cubes at home or anything similar, it could even be cubes of sugar or something, then you can maybe build these and have a see. If not, you try and draw them maybe, okay, or count on the screen. Just have a pause and have a look. And your investigation is, once you've done that actually, can you investigate, other than counting the number of cubes, is there a mathematical way to work out the number of cubes in each cuboid? And is that quicker than counting? What method would we use and how do we reckon? Okay, so have a pause, have a go, and then we'll go through it on the next slide, okay? So we've got 4 cubes, 8 cubes, 6 cubes, 12 cubes, 16 cubes, 27 cubes, 45 cubes, 64 cubes. You might have got some of the smaller ones right because they were quite easy to visualize, but as you got bigger, it did become quite difficult. Did anyone think of a different way than counting? Anything more mathematical might be quicker maybe? So, how many small cubes are inside the larger cuboid? And we've got our formula here. This just means what you have to do, okay? So for the volume of a cuboid, you need to times the length, times the width, times the height, okay? So there's 3 things you need to multiply for a cuboid, okay? Is that quicker? That's what we need to work out, okay? So you have 4 cubes, 2 cubes, and 5 cubes, okay? So you've got length, width, height. So 5 is your length, 4 is your width, and 3 is your height, okay? So if you do this, what answer will you get? So 5 times 4 times 3, or 4 times 3 times 5. Remember, it doesn't matter which way it's written. And you get 60, okay? 4 times 3 is 12, 12 times 5 is 60, okay? So how many small cubes are inside the larger cuboid here? Okay, what do we reckon? 7 times 4 times 6, 168. 7 times 4 is 28, times by 6. Now remember, you can do your column multiplication here to do 28 times 6. Okay, so that would be 60 centimeters cubed if it was in centimeters, or 168 centimeters cubed, because that's our units for the volume of a cuboid. Okay, so how can we work out the volume of a cuboid? Remember, height, width, length, okay? And multiply, we're multiplying here. Okay, that's our formula, length times width times height. And it's much quicker than counting. Now, these are just the beginning letter of the word, year 6, so length, width, height, that's all it is. Okay, so work out the volumes of these cuboids. 240 centimeters cubed, 6 times 10 is 60, 60 times 4 is 240, and remember we have to put centimeters cubed. Try the next one. 3 times 4 times 3, 36 centimeters cubed. Okay, so exercise 1, we're going to work out the volume of these cuboids if each small cube has a volume of 1 centimetre cubed, okay? So I would like everybody to have a go at this exercise, okay? And pause the side and have a go. And then you've got a problem solving to do at the end as well, okay? So pause and have a go. There are also, once you finish this lesson, there are also the workbook tasks for you to have a go in as well, okay? So here are our answers. Now all this depends on year 6 is if you can use your multiplication knowledge, okay? Use that multiplication knowledge. Now if you're struggling, you could maybe get a times table mat, or we could find one, or you can use column multiplication as well. Okay, did we get this for the problem solving? Did we work out this volume? So these were quite tough numbers. And therefore you had to divide the two by each other to find out that you would need 105 boxes. So can you work out the missing length of this cuboid? Pause and we'll have a go. So you know that you were multiplying to find the volume. Now that you have the volume, you need to do the inverse. So you need to divide. So 84 divided by 7 divided by 3. So that would give you 4 centimetres. So that missing side is 4 centimetres. Okay. Exercise 2. So my group, can you do exercise 2? Mr. Forster's group, you can go on to your workbook challenges now. Okay. So my group, can you pause the slide and have a go at the problem solving as well at the bottom, and then we can go through it. Okay, so looking at the answers for these ones, to find the missing side, another option would be as well to times the 4 by the 3, which would give you 12, and then you could do 24 divided by 12, which would give you 2. If you've got two sides, you could times multiply those sides together and then divide that by the volume. So for example, 3 times 2 is 6, divide that by 30 would give you 5. That's another way as well to do it. I find that way slightly easier than the slide of the previous slide. So work out the missing lengths on these cuboids, okay? So you knew the volume and you could probably see which side was missing here. This was quite a tricky one. But again, notice that these, because they're just the lengths of the side, they're not in centimetres cubed, they're just in centimetres. It's just your volume that is in centimetres cubed. Now your enrich problem. What is the smallest cube that you can put in the box that you can't fit another that's the same into it? So this was quite a tricky one. So you needed to work out the volume first, which I'm sure everybody got. So let's have a look. Post your answers into the assignment section and I will have a look and mark everyone's individual answers. So this is just a summary of what we've done so far. Now we've only looked at the green and the orange, okay? And your workbook tasks will be doing the same, looking at the green and orange, okay?